In April 2018, one tiny web analytics request inside Deepin's App Store triggered an accusation that would follow the Chinese Linux distribution for years. The request pointed to CNZ's, an analytics service. Deepin answered publicly, insisting it was measuring store traffic rather than harvesting private files. That denial did not end the argument. It changed it. The real question became harder. How do you prove what an operating system is doing when nobody is watching? 8 years later, that question is more relevant than ever, because Deepin no longer looks like an experimental Linux desktop hiding in a corner. Deepin 25 is polished, animated, AI-enabled, visually coherent, and increasingly designed to compete with the experience people expect from Windows. Meanwhile, Windows 11 has become more deeply connected to Microsoft accounts, cloud services, diagnostics, security layers, recommendations, and online features. So the comparison seems obvious. Put Microsoft on one side, Deepin on the other, watch the network, measure the resources, and declare a winner. But that simple contest breaks almost immediately, because the first popular claim about Deepin is already misleading. It does not have some magical lightweight kernel. Deepin is built on Linux. Windows is built on the Windows NT architecture. What users actually feel is the complete stack layered above those kernels. That stack includes drivers, desktop compositors, search indexers, update systems, security services, cloud clients, background daemons, and every process launched at login. And once those layers are separated, the story stops being China versus America. It becomes a much more revealing contest between two philosophies of control. The current Deepin line makes that contrast unusually sharp. By August 2026, Deepin 25.2.1 had arrived with search, file management upgrade, compatibility, and security fixes. Its newer desktop path centers on DDE and Treeland, Deepin's Wayland era compositor work, intended to improve responsiveness, multitasking, and visual fluidity. The high version kernel option had also jumped to Linux 6.18, with Deepin advertising scheduler, memory management, file system, and I/O improvements. Those are real engineering changes, but they are not proof that Deepin beats Windows. Vendor release notes describe improvements against earlier Deepin builds, not a controlled cross-platform victory. That distinction matters because operating system performance is one of the easiest things on the internet to fake with a single screenshot. Show idle RAM after boot, and Linux may look dramatically lighter. Show a game with proprietary drivers, and Windows may suddenly dominate the same machine. Measure file copies, and file system caching changes the picture. Measure battery life, and firmware behavior matters. Measure application launch, and prefetching changes everything again. A serious comparison therefore begins by refusing the one-number benchmark. Speed is to be divided into categories before it can mean anything. The first category is idle overhead, because that is where Windows has built much of its reputation for heaviness. A modern Windows 11 installation can maintain a wide collection of background components for updates, security scanning, search indexing, diagnostics, account integration, widgets, cloud synchronization, device services, and application maintenance. Some are dormant much of the time. Others wake according to events, schedules, connectivity, or user behavior. Deepin also runs background services. It has update mechanisms, network management, desktop daemons, indexing components, its app store, security tooling, user experience infrastructure, and optional connected features. The difference is not that one operating system has background processes while the other does not. The difference is how many responsibilities each default installation chooses to integrate. Deepin's reputation as a lightweight alternative becomes even more complicated when you examine its own hardware guidance. Deepin 25 recommends at least 8 GB of memory and a 64 GB SSD for smooth operation. Windows 11's published minimum memory requirement remains 4 GB, although that minimum says almost nothing about whether the experience will actually feel comfortable. So Deepin does not win simply because Linux is assumed to be smaller. DDE is a highly animated, visually ambitious desktop, and modern compositors, search services, AI integrations, and indexing all consume resources. Deepin is not trying to behave like a bare-bones window manager. It is trying to look and feel premium. Where Deepin can gain an advantage is architectural choice. A Linux desktop can often be stripped down more aggressively because components are replaceable, package-level dependencies are visible, and experienced users can remove services they do not want. That possibility is different from saying the default installation is automatically minimal. Windows can also be tuned, but Microsoft designs the consumer experience around a more tightly integrated platform. Security, update servicing, Microsoft account functionality, Defender, search, cloud hooks, and diagnostic infrastructure are not merely random bloat added without purpose. They are part of a system Microsoft is attempting to secure, support, monetize, and evolve across an enormous hardware ecosystem. Virtualization-based security is a good example. Windows can use its hypervisor to isolate sensitive operations and protect parts of the system from a compromised kernel. Memory integrity, also known as hypervisor protected code integrity, can enforce stronger rules for kernel mode code. Credential Guard can isolate secrets such as credential material using virtualization-based security. These protections are not free in the abstract. They introduce more machinery between software and hardware, and on some configurations, virtualization features can affect particular workloads. But turning that into Windows is slow because Microsoft added telemetry confuses security overhead with data collection. They are separate systems with separate purposes. Deepin 25 answers the integrity problem differently in one of its most interesting features. Its optional rock-solid system can make key operating system directories read-only and create snapshots around updates, allowing rollback when system changes fail. That approach reduces the writable attack surface and makes certain kinds of damage easier to reverse. This is where the speed comparison starts becoming philosophical. Windows spends resources maintaining defensive isolation inside a proprietary platform. Deepin increasingly experiments with immutability, snapshots, Linux permissions, and a more modular open-source environment. Neither design produces a universal performance winner because security posture changes what each platform is asking the hardware to do. Treeland is designed as a modern compositor for Deepin's desktop, and the Deepin team has repeatedly focused on window management, display behavior, interaction latency, and smoothness. Deepin 25.2 continued fixing high-frequency Treeland problems rather than pretending the transition was already finished. That matters, because a desktop can benchmark well and still feel terrible if focus changes, animations, input, or multi-monitor behavior stutter. Deepin's kernel work tells the same story. The project's 6.18 based high-version kernel includes changes Deepin says improve memory allocation, swap behavior, file system I/O, and interactive scheduling. The project also integrated a Bohr-derived scheduling approach aimed at improving desktop responsiveness under load. But here's the trap. Feels faster and finishes work faster are not the same metric. A scheduler can prioritize interactive tasks, so the pointer, windows, and foreground applications remain responsive while background work takes slightly longer. That can produce a dramatically better subjective experience without increasing raw throughput. Windows performs similar balancing acts through different scheduling, caching, prefetching, priority, and power management systems. On hardware with excellent Windows drivers, application launch and GPU behavior can be extremely optimized. On hardware with cleaner Linux support, Deepin may feel immediate and less obstructed. The machine under the operating system can decide the winner before the desktop even appears. That becomes obvious with graphics. Linux has made enormous advances in open GPU drivers and gaming compatibility, but Deepin is not automatically the best Linux distribution for every graphics workload. Proprietary NVIDIA behavior, hybrid graphics, creative applications, anti-cheat systems, specialized peripherals, and vendor utilities can all shift the advantage toward Windows. And if a Deepin user has to run a Windows application through a compatibility layer, a container, a virtual machine, or a web replacement, the supposed efficiency advantage can disappear. Sovereignty that breaks the workflow is not a practical victory for the person who still needs the workflow. The third category is disk and file performance, where simplistic comparisons become even more dangerous. Deepin's current kernel and file systems can be extremely capable, and the project has specifically highlighted improvements in XT4 and XFS behavior. Windows relies primarily on NTFS for the normal desktop experience, with decades of compatibility requirements attached to it. This is why any claim that Deepin simply outpaces Windows in raw performance needs a benchmark matrix, not a slogan. Without identical hardware, repeated runs, controlled power settings, equivalent drivers, equivalent security states, and clear workloads, the conclusion is advertising rather than measurement. Microsoft openly documents that Windows 11 sends required diagnostic data. Optional diagnostic data can be disabled, but the required tier exists to help Microsoft maintain security, compatibility, reliability, and servicing. Microsoft also publishes extensive lists of diagnostic events and fields, including information about hardware state, security configuration, crashes, software, and system behavior. That documentation is important because telemetry is often discussed as if it were one secret pipe carrying everything a user does. In reality, Windows diagnostics are divided into categories, purposes, settings, and additions. Optional diagnostics can include much richer information, while required diagnostics continue even when the optional switch is off. The privacy concern is therefore not that Microsoft secretly admits nothing. In many areas, Microsoft documents an extraordinary amount. The concern is that a consumer Windows installation is designed around an ongoing relationship with Microsoft's infrastructure, and ordinary users cannot reduce that relationship to zero simply by switching off one setting. The connected user experiences and telemetry service, commonly associated with DiagTrack, exists specifically to support diagnostic and usage information flows when configured. Windows Update, Defender, Activation, Certificate Systems, Time Services, the Store, Account Services, Cloud Features, and other components may also communicate for reasons that are not all telemetry in the narrow diagnostic sense. That distinction is crucial during packet capture. A DNS request is not proof of spying. A TLS connection is not proof of exfiltration. An operating system contacting a vendor server may be checking updates, validating certificates, retrieving icons, synchronizing time, loading content, authenticating an account, or sending diagnostics. You need endpoint ownership, process attribution, payload context where legally and technically observable and reproducible triggers. Deepin's own privacy policy says that during software updates, it may collect the operating system version, a device identifier, and CPU information to help deliver the correct update. Its separate user experience program agreement says participation can be enabled manually during installation or in settings and can be turned off, after which the program says collection under that program stops. That means the strongest privacy argument for Deepin is not Deepin sends nothing. That claim is contradicted by Deepin's own published policy. The stronger argument is that at least some experience-oriented collection is explicitly framed as optional, while the Linux environment gives advanced users more opportunities to inspect services, packages, processes, sockets, and source code. Even that advantage needs qualification. Open source is not a magical privacy certificate. You can publish millions of lines of code and still connect to cloud services whose server-side behavior the user cannot audit. You can ship an open client that downloads proprietary content. You can also build an entirely transparent data collection system. Source availability tells you what can be inspected. It does not automatically tell you what has been inspected well. Deepin's past proves why this matters. In 2018, critics discovered CNZZ analytics inside the web-based App Store experience and interpreted the connection as evidence of spyware. Deepin publicly said the service collected anonymous website statistics, such as browser user agent and screen resolution information, comparing the role to web analytics rather than private file collection. The historical lesson is not that every accusation against Deepin was false. It is that network evidence needs interpretation. One connection can be real, while the accusation built around it is exaggerated. The same standard has to apply to Microsoft, Google, Apple, Ubuntu, Deepin, or any other system. Today, Deepin's connected surface is also larger than it was in 2018. Deepin 25 includes an app store, account infrastructure, intelligent search, update services, and increasingly visible AI functionality. Deepin 25.1 promoted integrations with models including DeepSeek and GLM, while also supporting local or privately deployed models when web search is disabled. That last detail matters because privacy can change by mode. A local model processing local text is a fundamentally different data path from a cloud model receiving a prompt over the network. An operating system can therefore be private in one workflow and highly connected in another without either description being universally true. Deepin 25.2.1 also expanded intelligent local file search. It can use clues such as file type, location, modification time, document content, and text recognized in images to find material more naturally. That sounds invasive until the architecture is examined. Local indexing can increase privacy risk on the device without necessarily transmitting the indexed content to a remote server. This is a subtle point that privacy marketing often ignores. Data does not have to leave the machine to become sensitive. A local index can expose information to another local account, a compromised process, a backup system, or forensic access. Privacy is not just, did a packet cross the router? It is also where data is stored, how it is protected, and which process can read it. And this is where nationality enters the debate in a way that is emotionally powerful but technically weak. Deepin is developed in China, and its published privacy policy states that Union Tech Software and affiliates operate the relevant services, with governing law language tied to the People's Republic of China. Microsoft is an American corporation operating a global cloud and compliance infrastructure under a different legal environment. Those jurisdictions matter for legal process, corporate obligations, data handling, government requests, and user trust. But nationality alone cannot tell you what packets a specific computer sends. A Chinese product is not automatically spyware, and an American product is not automatically private. The only useful technical question is what the software does, under which configuration, and whether the user can verify or change it. A Linux distribution gives the owner more leverage over the operating system itself. Services can often be disabled or removed. Network destinations can be blocked without fighting a platform that assumes they must remain available. Packages can be replaced, desktop components can be swapped. The kernel and large parts of user space can be inspected, rebuilt, patched, or replaced entirely. With Windows, users can configure enormous amounts through settings, group policy, PowerShell, enterprise management, firewall rules, and security policy. But the platform remains proprietary, and consumer editions are not designed around the assumption that users will rebuild or substitute core Windows components. Control is extensive, but it operates inside boundaries Microsoft defines. That is the difference between privacy settings and architectural sovereignty. Privacy settings ask the vendor for fewer data flows. Architectural sovereignty asks whether the vendor can be removed from the trust chain at all. Deepin does better on that question because it inherits the replaceability of the Linux ecosystem. But it does not completely remove Deepin or Union Tech from the trust chain by default. Official repositories, update infrastructure, App Store services, account systems, and Deepin-specific applications still create relationships with project-controlled infrastructure unless the user deliberately changes them. Windows hides much of that cost by centralizing the experience. Drivers arrive through established channels, commercial software targets the platform first, enterprise vendors certify it, game developers test it, hardware makers ship utilities for it, and support desks understand it. That ecosystem is a form of performance too, because time spent fixing compatibility is time the benchmark never measures. For a technical user who wants a clean workstation for coding, browsing, local media, office work, terminal tools, and open applications, Deepin can offer a compelling experience. If the hardware is well supported, the desktop may feel less crowded by vendor prompts and cloud integrations, and unwanted components may be easier to remove. For a user, dependent on Adobe applications, specialized engineering software, vendor-specific peripherals, enterprise identity tooling, mainstream anti-cheat gaming, or proprietary corporate clients, Windows can remain dramatically more efficient in practice, even if it uses more resources at idle. The fastest operating system is the one that runs the required application natively and reliably. By August 2026, Microsoft's own release information still treated Windows 11, 25H2, and 24H2 as the mainstream path for existing systems, while 26A1 was scoped to select new devices, rather than a normal feature update for existing PCs. That matters because comparing Windows 11 without naming the build can hide substantial differences in services, drivers, and security defaults. Start with one physical machine and image the same SSD separately for both systems. Update firmware once. Use equivalent power modes. Record exact kernel, build, driver, and desktop session versions. Let both systems complete updates and indexing before measurements begin. Disable third-party startup applications on both, but do not selectively cripple one platform's default security while leaving the other intact. Then separate idle measurements from workload measurements. Log CPU wake-ups, memory pressure, disk I/O, network connections, and power draw over a fixed quiet period. Reboot repeatedly and measure boot to interactive time, not merely the moment a desktop wallpaper appears. Launch the same cross-platform applications multiple times and distinguish cold launch from cached launch. For throughput, test compression, compilation, browser workloads, media encoding, file operations, and GPU tasks using software that behaves comparably on both systems. For gaming, document the exact renderer, driver, API translation layer, frame time distribution, and security state. Average frame rate alone can conceal stutter that determines whether the system actually feels fast. For privacy, place the machine behind a controlled gateway. Capture DNS, destination addresses, connection timing, byte counts, and the process responsible for each flow where possible. Repeat the capture after a clean boot, after opening settings, after checking for updates, after opening the store, after search, after account login, and after enabling or disabling optional diagnostics. Most importantly, classify each connection. Update traffic belongs in one category, certificate validation in another, authentication in another, content delivery, crash reporting, security reputation checks, time synchronization, search, ads, AI requests, and diagnostics must be separated. Counting domains without identifying purpose produces a scary number, not a privacy audit. If that process is followed, Windows will almost certainly reveal a broad relationship with Microsoft-operated infrastructure because the operating system is designed as a connected commercial platform. Deepin will also reveal legitimate network relationships with repositories and services, and optional features can expand that surface. The interesting result is not whether either system touches the internet. It is how much communication remains after the user disables what can reasonably be disabled. Windows 11 makes required diagnostic collection part of the supported consumer operating system model. Microsoft explains the purpose and exposes substantial documentation, but required diagnostic events remain part of the platform. Deepin's user experience program is described as manually enabled and revocable, while its published privacy policy separately discloses narrower system update information collection. This does not make Deepin anonymous. It makes the control boundary different. A Deepin user can also move farther away from project services by replacing components, changing repositories, using alternative stores, blocking endpoints, or migrating to another Linux desktop while keeping the same underlying ecosystem. The exit path is part of the privacy story. Windows has an exit path too, but it is usually an exit from Windows rather than a replacement of Windows from within. You can remove applications, disable features, use local software, avoid a Microsoft account in scenarios where supported, and apply enterprise policies where available. You cannot transform the proprietary Windows core into a community-controlled operating system. That gives Deepin a structural advantage for people whose definition of privacy includes auditability and replaceability. Yet Deepin carries a trust paradox of its own. Many privacy-conscious users choose Linux specifically to reduce vendor dependence, then hesitate because Deepin's corporate and jurisdictional relationships introduce a different vendor trust question. Deepin should be judged by its source, packages, policies, network behavior, update design, repository control, reproducibility, security response, and whether optional data collection really stops when disabled. Microsoft should be judged by the same categories, adjusted for the fact that its source is not generally available and its telemetry model is more formally integrated into the supported platform. Under that standard, Windows loses the minimalist privacy contest. Required diagnostics alone mean a normal Windows 11 installation is not designed to be a silent, vendor-independent appliance. Its broader cloud-connected experience increases the number of components that may communicate, especially when users enable account synchronization, store services, cloud search, recommendations, optional diagnostics, or other online features. But Windows does not automatically lose the security contest. TPM requirements, secure boot, Defender, reputation systems, virtualization-based security, credential isolation, code integrity protections, enterprise policy, and a huge security response operation can provide defenses that matter far more than shaving a few background processes from Task Manager. Deepin's Open Foundation does not automatically win security either. Linux permissions, open development, immutable system options, and rapid kernel evolution are powerful tools, but security also depends on patch speed, package quality, repository integrity, browser updates, driver maintenance, application sandboxing, and the behavior of every privileged component installed by default. This is why privacy and speed cannot be compressed into one score. The fastest configuration can be the least hardened. The most private configuration can lose cloud convenience. The most locked down configuration can break applications. The most compatible platform can require the deepest vendor relationship. If the goal is raw desktop sovereignty, Deepin has the stronger foundation. The user has more practical ability to inspect, replace, block, rebuild, or abandon components without abandoning the entire Linux software world. That is a meaningful difference from Windows, and one Microsoft cannot solve with another privacy toggle. If the goal is guaranteed superior performance, the evidence is not there. Deepin's modern kernel, Treeline work, and reduced dependence on some Microsoft-style integrated services can make it feel extremely responsive on suitable hardware. But Windows can outperform it in workloads where drivers, commercial software, GPU stacks, hardware tuning, or native application support favor Microsoft's ecosystem. And if the goal is zero telemetry, neither default experience deserves that label without qualification. Windows explicitly retains required diagnostic data. Deepin discloses system update information collection and offers an optional user experience program, while connected apps and services create additional network behavior depending on what the user enables. The more interesting conclusion is that Deepin challenges Windows not by proving China has built a universally faster desktop, but by exposing how much of modern computing performance is actually a choice about what the operating system is allowed to do in the background. Windows tends to bundle more of those responsibilities into a standardized connected platform. Deepin gives the user a system that can be pushed farther toward local control, but its increasingly ambitious desktop also shows that Linux distributions face the same temptation. Add intelligence, search, accounts, stores, assistants, and services until the lightweight alternative becomes a platform of its own. That may be the real danger for Deepin. Its greatest advantage over Windows is not that its interface is prettier or that its kernel number is newer. It is that users can still see a plausible path from polished convenience back toward a smaller, more inspectable system. If that path remains open, Deepin can grow without surrendering the principle that made the comparison interesting. If the path closes behind opaque services, mandatory accounts, unavoidable cloud dependencies, or non-removable data collection, then Deepin would simply recreate the problem its users were trying to escape. Microsoft faces the opposite challenge. Windows already has the ecosystem, compatibility, enterprise reach, driver support, and massive security infrastructure. Its weakness in this comparison is trust created by necessity. Many users depend on Windows even when they would prefer less integration, less account pressure, and fewer mandatory relationships with vendor infrastructure. That difference changes the meaning of choice. Choosing Deepin is often an active decision to accept some compatibility risk in exchange for more control. Choosing Windows is often an active decision to accept more platform integration in exchange for compatibility and support. Go back to that 2018 controversy. Critics saw an analytics request and jumped to the most dramatic interpretation. Deepin saw ordinary web statistics and underestimated how sensitive Linux users were to undisclosed network behavior. Both sides were arguing about something larger than one analytics service. Who gets to decide what a computer reveals? The meaningful test is whether the owner can understand the system's behavior, measure it, change it, and keep using the machine after saying no to the vendor. On that test, Deepin currently offers more room to take control than Windows. On universal speed, there is no honest winner. On privacy, Deepin has an architectural edge, but not a blank check. And on compatibility, Windows remains extraordinarily difficult to displace. The operating system that feels most sovereign is not the one that promises the fewest packets. It is the one that still belongs to you after you start turning them off.